Hi, welcome to Future Unwired. Back in the late 1980s and early 90s, Japan was the unquestioned titan of the microchip world. Japanese companies control over 50% of the global semiconductor market. And 6 of the top 10 chip makers in the world were Japanese, including household names like NEC, Toshiba, and Hitachi. But that dominance began to slip away in the 2000s due to a combination of geopolitical pressure, structural blind spots, and economic shifts. By 2020, Japan's market share in chip manufacturing had plummeted from more than 50% down to under 10%. Today, Japan is looking to turn things around with an aggressive, government-backed revitalization campaign. Leading the charge is Rapidus, a state-backed public-private initiative designed to restore Japan's capabilities in cutting-edge semiconductor manufacturing. According to the Japanese government, Rapidus is a national security priority essential to restoring the country's technological sovereignty. So, how exactly does Rapidus plan to pull this off? And how likely is it to succeed? That is what we're breaking down today. By now, you've probably heard of TSMC. The Taiwanese chip-making giant commands over 70% of the global contract chip-making market. Its competitors, such as Samsung Foundry and Intel, hold only single-digit market shares. When we narrow the scope to leading-edge nodes and advanced AI processors, TSMC holds an effective monopoly with over 90% of market share. TSMC manufactures virtually all of the world's most advanced AI chips for tech titans such as NVIDIA, Apple, AMD, and Qualcomm. So, why did TSMC become so dominant? First, building a modern fabrication plant or fab costs upwards of $20 billion. Very few companies on Earth can afford this level of capital investment every few years. Second, utilizing extreme ultraviolet lithography machines or EUV requires immense operational expertise. Competitors like Intel and Samsung have suffered years of yield rate delays attempting to catch up. Third, unlike Samsung and Intel, TSMC does not design its own consumer products. That means partners like Apple, NVIDIA, and AMD can trust TSMC with their proprietary designs without fear of IP theft or competition. Given those massive barriers, how can Japan even consider catching up to players so far ahead in the race? Japan's response was a bold, government-led initiative to build a domestic foundry capable of producing 2nm chips from scratch. For this purpose, a unique public-private partnership was founded in August 2022, alongside 8 major Japanese industry leaders: Toyota, Denso, Sony, NEC, SoftBank, Kioxia, NTT, and MUFG Bank. At the start, these Japanese corporations provided a combined seed capital of around $55 million, while the Japanese government committed over $15 billion in non-dilutive subsidies and grants to fund pilot lines and fab construction. All this investment is tied to an extraordinarily aggressive timeline, attempting to achieve a high-volume mass production of 2nm logic chips by 2027. However, money is not the only requirement for an ambitious 2nm foundry. Know-how and expertise are just as essential. To put that into perspective, it took approximately 7 years for TSMC, a company with over 4 years of industry experience, to achieve high-volume mass production of 2nm nodes. To bridge that gap, the Japanese government formed a strategic partnership with IBM to license 2nm gate-all-around technology developed at the Albany Nanotech Complex in New York. In return, IBM earns revenue from licensing fees, reduces its over-reliance on TSMC, shares massive R&D costs for future developments, such as advanced chiplet packaging, and gains direct access to Japan's elite ecosystem of materials and equipment suppliers. With those deals locked in, Rapidus broke ground on its first mega fab in September 2023, located in Chitose, Hokkaido. Rapidus chose this spot for its vast open land, giving them plenty of room to expand, plus an abundant supply of high-purity water needed for chip washing. Additionally, the region offers huge potential for local zero-emission renewable energy to align with global green manufacturing standards, a cool climate that reduces industrial cooling overhead, and a direct proximity to the new Chitose airport. So far, Rapidus is moving fast and staying right on schedule. In 2024, primary structural construction of the Chitose fab was completed, while Japanese engineers traveled to IBM's Albany facility to master the 2nm manufacturing process. In early 2025, ASML EUV lithography machines were installed, followed by the launch of a pilot line running test wafers to refine yields and calibrate machinery. With things going according to plan, Rapidus completed a major private sector funding expansion in 2026, totaling approximately $1.1 billion. 32 private companies participated, including Fujitsu, Canon, Honda, and Fujifilm, while founding members increased their stakes. The Japanese government also increased its participation by transitioning from just providing subsidies to taking direct ownership. It invested $1.6 billion in direct equity. But what actually makes Rapidus different from a giant like TSMC and its more than 40 years of experience? Rather than attempting to compete directly with TSMC on sheer volume or scale, Rapidus focuses its business model on three key advantages: speed, flexibility, and lower prices. The standard TSMC process typically uses a mix of batch and single wave processing, taking approximately 120 days for a completed wafer batch. Rapidus, however, is betting on its proprietary RAMS model to cut standard production turnaround times down to 50 days. In special cases, that number can drop as low as 15 days. In simple terms, instead of processing silicon wafers in large batches, Rapidus processes wafers one by one using automated real-time data tracking. On top of that, unlike TSMC, chip cutting, stacking, and packaging are all done under one single roof, eliminating the logistics, handoffs, and waiting times between separate factories. When it comes to flexibility, Rapidus is positioning itself as a boutique foundry aimed at companies needing smaller, specialized batches of custom chips, unlike the massive global volume required by clients like Apple or Nvidia. Finally, to win clients over, Rapidus is targeting a price range of $18,500 to $21,500 per wafer, whereas TSMC's 2nm wafers are estimated to cost around $30,000 each. With funding coming in and the project moving at full speed, Rapidus has secured initial commitments from several high-profile companies for prototyping, IP development, and early adoption. Although a full list of prospective clients has not been made public yet, partners like Tenstorrent and IBM are already confirmed. Additionally, several of its investors, such as Toyota and Sony, are expected to source chips from Rapidus in the future. While the progress seen with Rapidus looks promising, critics and industry skeptics still have major doubts. For example, semiconductor manufacturers rely heavily on cumulative operational experience. There's also a real worry about a severe shortage of younger domestic engineering talent needed to run a 24/7 commercial operation. It is also unclear whether Rapidus will be able to match TSMC's yield performance and cost efficiency. Analysts estimate that Rapidus' current early production capacity is around 7,000 wafers per month, while a flagship TSMC fab produces around 100,000 wafers monthly. Finally, critics question whether private capital will step up to fill the funding gap if government subsidies begin to taper off or face political friction. Rapidus is indeed a very ambitious project, and if it pays off, it will create a vital alternative to the near monopoly we see today with TSMC. The timeline is extremely tight, and we'll see how the next chapter of this ambitious gamble unfolds over the coming months. So, what do you think? Is Rapidus a great promise or a long shot gamble? Let us know in the comments below. Anyway, thank you for watching until the end. I'm Rafa, and I'll catch you in the next one. Have a good one.